Hi all, my name is Catherine, Assistant Professor from the Department of AML, SNS College of Technology, Coimbatore. Today in our lecture series, we are seeing about the substitution technique. So today we shall see about the Hill cipher. Earlier we have seen about the Playfair cipher and Caesar cipher, and today we shall see about the Hill cipher. This is also an interesting multi-letter cipher, which means you are taking multi letters at a time and you are going to encrypt that, not one letter at a time. You're going to take multi letter at a time. It was developed by the mathematician Lester Hill in 1929. So you could understand how the encryption goes way back in 1920s. So this uses makes use of modulo arithmetic and matrix multiplication and matrix inverses. Hence, it is more mathematical cipher compared to other ciphers. So before getting into this, this modulo arithmetic and matrix multiplication involves numbers. We cannot simply use the text or the letters, alphabets, just like that to do a matrix multiplication. So for every alphabet from A to Z, you are going to substitute a number from 0 to 25. For example, instead of A, you are going to whenever a letter comes in the plain text, instead of that you are going to put it as 0. Only then you can do the matrix multiplication. So once after all this multiplication is done, and when you receive numbers, when you receive the answer in numbers, right, again you have to put the alphabets in place of numbers to get the encrypted message or the decrypted message. So here we'll see how the encryption happens. So for encryption, you already know that encryption involves two things, key and a plain text. So here what we are doing is we are taking a key, we are doing it matrix multiplication with it, and we are doing a modular function with 26. Why we are doing with 26? Because this alphabets involves 26 letters. So we have to basically do a 26 modular function. So here K is a key matrix and P is the plain text, which will be kept in a vector form. Matrix multiplying these two terms produces the encrypted ciphertext. So here, for better understanding, we'll do it with an example. First, you pick a keyword to encrypt your plain text message. Let's work with we are taking some random keyword DCDF. So how this DCDF is written is DC is written in a column and DF is written in a column. Next, what we are doing, we are going to convert these letters into numbers so that you can do your matrix multiplication. So what we are doing further, in place of D, you are going to substitute it with 3, because in previous slide we saw D has number 3. So in place of D, you are substituting it with 3, and C with 2, and F with 5. So now this letter alphabet matrix is converted into a numerical 2 cross 2 key matrix. So now we will convert our plain text to a message format. Since our key is a 2 cross 2 matrix, the vector needs to be 2 cross 1 for matrix multiplications. You know that, right? So here the plain text which we are taking is code. We are taking code. So again, you are writing CO this way and D this way. How we are going to convert? First step, you are going to convert it into numbers. Instead of C, you are replacing it with 2. Instead of O, you are replacing with 14. Instead of D, it is 3, and E, it is 4. Next, what happens? You have to, the formula is nothing but key into plain text mod 26. So obviously what you have to do, you are taking the key is nothing but DC, DF, we have converted into a key matrix, and what is the plain text which we are taking? C and O. So C and O, what did we convert it to? 2 and 14. Now we'll do the matrix multiplication. How do we do the matrix multiplication? Rows into columns plus rows into columns. When you do all these things, what answer you are getting? 48 and 74. So remember, we have to do what? Mod 26. So with the resulting answer, what we are doing? We are doing a modular function 26, and the answer what you are getting 22 and 22. So you go back to that table. Instead of 22, what is written? W. So you replace it with W and W. So same thing applies to D and E. You take the key matrix, you convert it into a numerical matrix, you take the plain text, convert it into numerical matrix, and then you start doing a matrix multiplication, rows into columns plus rows into columns. What do we get? 21 and 26. When we do modular arithmetic with it, mod 26, what do we get? 21 and 0. So you go back to the table. What do we have for 21? We have B. What do we have for A? 0, we have A. So the plain text code is now converted into what? The ciphertext WWVA. So anybody who is having able to access, having an access to read this message also, they will not be able to understand what we have done. WWVA is somewhere far away from code. There is no connection between code and WWVA until and unless he sits, takes his time, try to crack the code. There are people who does that. That is why we make our computations and algorithms even more secure, more complicated, so that it's not easy for the hacker to hack it right away. At least it will take time. Some will lose. Some the basically what the attackers, what they do is, before getting into this breaking a thing or tampering an information, they will understand whether it is worth their time. So that information should be that worth, right? Only then, instead, when you steal somebody's username and password, you should understand how far it is really worth to do that. Is it really necessary? With that user credentials, will you be able to access so many things? Will in return, does it going to benefit you? So when you keep your algorithms more computational and complex things, the attackers has to spend more time in cracking that information. We basically call the attackers as cryptanalysts. Okay, cryptanalyst is someone who tries to crack the algorithm. So what they do is, when you have such complicated techniques, they will only hack that information if it is really worth. The hacking time will be more and more rather than doing the regular thing. So when you keep it more complicated, it's hard to encrypt the original message. I hope you understood Hill Cipher. Let us continue in the next lecture series. Thank you.